All right, everybody. I want to go over and talk about permutations and combinations. All right, so I'm going to start off permutations first. Now, there's some background information I want to go over permutations in this study. And I want to explain first about a factorial and what it is. And it's really a very simple thing. If you just remember, it's a way of multiplying. Okay, and we symbolize it with this. So let me take this equal sign off here. So that's what we use. And n, back to the letter here, n factorial can be represented mathematically like this. N times n minus 1 times n minus 2. And you keep doing this all the way down till you get to 1. So, for example, we have 5 factorial. It's 5 times 4 times 3 times 2 times 1 equals 120. Okay? So where did we get 4 from? Well, look up at just above. We have n minus 1. And n minus 1 in this case would be 5 minus 1 is 4. N minus 2 is 5 minus 2. We would get 3. That's all a factorial is. Now, there's something else I want to tell you about a factorial. 0 factorial is not equal to 0. It's equal to 1 by definition. Okay? It's equal to 1. All right, let me clean this off. All right. So let me explain something. There is a definition. P, N, R. And it is represented by n factorial over n minus r factorial. Okay. Now, supposing that r is the same thing as n, well, it would just be n. And you would have n factorial. And what is n minus n factorial? That's 0 factorial, which is just going to be n factorial divided by 1, which is n factorial. That's all. So, for an example, how many ways can 6 horses finish a race? Well, there are 6 objects, 6 horses, and there's 6 places. So our P, we have 6, 6. That'd be 6 factorial over 6 minus 6 factorial, which is 6 factorial, which you know, 6 times 5 times 4 times 3 times 2 times 1, and we end up with 720. So, how many ways can 6 horses finish a race? So here's the problem. How many ways can 6 horses finish a race? 720. All right. So let's look at another example where we didn't have this one. This type of situation. All right. All right, so let's say we have 5 runners in a race. We have 5 runners that are running a marathon. Assuming that each runner has an equal chance of finishing in a given position, how many different possibilities are there for first and second place? So we have 5 runners, and we want to know what are the possibilities for first and second place. All right, for first and second place. So that is a permutation. Now in this case, we have 5 runners, and we want to know about how many different possibilities are there for first and second place. So we'll have 5 factorial divided by 5 minus 2 factorial now that's going to be 5 times 4 times 3 factorial divided by 3 factorial. Okay? The 3 factorials can cancel, and we end up with 20. Okay. All right. So let me give you some examples of some different situations that you could possibly see and why that is the way it is. So as an example, let's say we had 6 factorial. That's simply 6 times 5 times 4 times 3 times 2 times 1, which is 720. You can also divide. So 6 factorial over 4 factorial. Now, we know that this is 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. Well, this 4 times 3 times 2 times 1 and this 4 times 3 times 2 times 1, they cancel. And you end up with 30. Well, why not, instead of writing it all out like that, why don't you just stop when you get to 4 factorial, because 4 factorial divided by 4 factorial can cancel and you're left with 30. So you can do that if you like. All right, so let's look at another example. This time, let's look at combinations. So to find the number of combinations of n objects taken r at a time, we can use this formula. It's very similar. There's one small change in it. Divided by n minus r factorial over r factorial. Okay, now let's say that we have 15 soccer trophies, but we only have room to put 9 of them on a shelf. How many different combinations are possible for just those 9? So we have 15 and 9 right here equals, so we still have our n, which is 15 factorial over 15 minus 9 factorial times 9 factorial. Now, this kind of a problem, you will have to use your notes. I'm sorry, I meant to say you are going to have to use your calculator to do this. We end up with 5,005. All right. All right, so I'm going to post a couple problems for you related to this, and I want you to get in touch with me to discuss. Contact me through Skype or through email in regards to reference to how to do these and accomplish these problems.